E-comment on the topic parathyroid gland. Introduction. Parathyroid is composed of 4 small glands embedded in the posterior aspect of the thyroid gland. Its main function is the production and secretion of parathyroid hormone, PTH, responsible for maintaining serum calcium homeostasis. The parathyroid glands contain 2 main cell types, chief cells and auxophil cells. Chief cells. The chief cells are the functional cells of the parathyroid gland, responsible for both synthesizing and secreting parathyroid hormone. The G-protein-coupled transmembrane receptor, calcium-sensing receptor, on the surface of chief cells responds to low serum calcium and activates translation and secretion of PTH. Auxophil cells, also known as oxyntic cells, these cells have no recognized endocrine function. The proportion of auxophil cells in the parathyroid glands increases with age. Function. The parathyroid gland's function is to maintain serum calcium homeostasis through the synthesis and release of PTH. At the bone, PTH inhibits osteoblast activity and stimulates osteoclast activity, leading to bone breakdown and calcium release. PTH increases calcium reabsorption at the kidneys and blocks phosphate reabsorption from the tubules. PTH also acts on the kidneys to stimulate the formation of vitamin D. Vitamin D is an essential component of calcium and phosphate homeostasis, yielding its effects on the kidneys and gastrointestinal system. Function in skeletal system. PTH works at the cellular level by indirectly stimulating osteoclasts to break down bone. PTH binds to cell receptors on osteoblasts, stimulating the release of receptor activator of nuclear factor kappa B ligand, RANKL. RANKL binds to its receptor on osteoclast precursors, stimulating them to fuse into mature osteoclasts, thereby increasing calcium reabsorption from bone. Function in renal system. PTH has 2 main roles in the kidney. It works in the thick ascending loop of Henle, distal convoluted tubule, DCT, and collecting ducts to increase reabsorption of calcium by upregulating TRPV5, a calcium transporter on the tubular epithelium. PTH also binds to sites in the proximal tubule that block phosphate reabsorption. Therefore, the net effect of PTH is to decrease calcium excretion and increase phosphate excretion in the urine. Function in gastrointestinal system. Calcium absorption occurs in the small intestines, with 70% to 80% absorbed in the ileum. Although PTH has no direct effects on the small intestine, the downstream effects of PTH on vitamin D synthesis occur at this level. Vitamin D increases calcium and phosphate absorption from the gut. Vitamin D receptors occur along the entirety of the gut epithelium, and studies have shown that both paracellular and transcellular absorption of calcium increase when stimulated. Vitamin D increases transcription and translation of calcium transport proteins in the epithelium, including TRPV6, calbindin, and ATP-dependent calcium pumps. Thank you.